and action.
Okay. All right. Well, hey, good afternoon. Thanks everybody for joining. I see a lot of familiar faces, but for those that I haven't had a chance to meet yet, my name is Scott Ayler. I'm the Corporate Vice President and General Manager of the Data Center business at AMD. Very glad to have you with us this afternoon.
And hey folks, my name is Daniel Bounds. I look after our go-to-market and marketing operations for our data center products.
Great. Well, hey, clearly we had kind of an action-packed and news-filled morning, and we wanted to kind of circle back and cover some of those topics, but then leave plenty of time for questions and hopefully some good answers for you. So first, to kind of lead off, one of the major announcements that you saw was really our partnership with AWS, with AWS offering available for sale today their M and R instances built around EPYC technology, with their T instances to come in a few weeks. This is very significant. They're the #1 player in the market, and they offer kind of a very simple and compelling value proposition, and you get their highest performance, highest volume instances at a 10% lower price. So we're very excited in what we were able to accomplish in the partnership with AWS. Also, we talked a lot about cloud momentum. So AWS being #1 in the market is kind of a very strong capstone to the momentum that we have in cloud. But we have many cloud providers, both big and small, that are adopting EPYC technology. So when you look at many of the Super 7, companies like Baidu, companies like Tencent, companies like Microsoft Azure, that are all adopting EPYC technologies in unique and interesting ways, as well as the kind of second wave cloud providers, companies like Packet Hosting and iVelocity and Hetzner in Europe, that all see the value in EPYC is able to bring. We also talked about, with all the excitement that is cloud and all the growth that is cloud, the on-prem environment is still very, very important. And there's a set of circumstances as licensing and support of existing OS infrastructure, things like Windows Server 2008 expiring. If you look at ESX 5.5 going end of service, there's a lot of reasons for people to be upgrading their virtualization infrastructure. And Forrest shared a little bit about that. And we offer a great opportunity in doing that for people to really save dramatically with their virtualized infrastructure by adopting our single socket solution. In this case, we show an example of partnering with VMware, how our customers and partners on-prem are able to save up to 45% total cost of ownership leveraging our single socket solution. We also heard this morning about momentum and high performance computing. The fact that we have a #1 position in the world as it relates to floating point performance is indicated by the SpecFP 2017 benchmark. But as interesting as benchmarks are, they only matter when you can put them to real use. So we are now kind of taking that leadership floating point capability built around Naples and now deploying that across a variety of departmental, academia, research. You even see kind of exascale workloads starting to adopt EPYC based upon the partnership that we have and the announcement that we have with Cray around Shasta. But I think probably one of the most anticipated things was a conversation about early exposure to Rome. The fact that we are talking about the fact that we have up to 64 cores, up to 64 Zen 2 cores, with Zen 2 offering incremental instructions per clock benefit. The ability to leverage that in the same platform, and really the ability to now take certain system level attributes like PCI Gen 4 and really kind of innovate much more at the system level. So a very strong momentum and a very strong set of conversations that we had this morning. So we have a few things to show you here that are up front. So first is in the middle, the centerpiece that you see here with all the EPYC stickers. This is actually one of our early Rome evaluation platforms. So this is what you actually, the demo that you see running on stage is actually running on this type of system. that is actually behind the noise abatement screen that we have here. No, we're not trying to keep you from attacking the demos. We're trying to keep the noise level down. But again, think of this as an early evaluation system. It has all of the debug and kind of remote capabilities. But right next to it, we actually have our Rome reference architecture, or evaluation platform, that is a server rack-based architecture. So this is a 2-socket implementation that allows you to put 2 ROMs in, as well as a wide variety of networking and GPU cards that go with that. Okay, and then to your far right is where we actually will run some demos for you. So I'll move over there to start the demos. So what we're going to show you is we're going to show you 3 demos. So if you recall, what we showed on stage is a set of sequences of a Skylake 8180 versus a Rome. So what we have here is we have in the monitor that you see on your far left-hand side. This is a dual 8180M Skylake system. Forrest mentioned on stage that these processors retail for $13,000 a piece. So that means you have $26,000 worth of CPU hardware in the system. The best system that money can buy from Intel. On the far right-hand side, you actually have a dual-socket Naples system. So this is current generation hardware pulled from our manufacturing partners in production. And then in the middle, we actually have a 1P Rome system. Actually is another version of this system that is running right behind the screen here. And so what we are running is we're actually running a benchmark that is very commonly used to evaluate floating point performance called C-Ray. So this is a Linux-based benchmark. So it's a benchmark that runs under a Linux ecosystem. We happen to be running Ubuntu 1804 with Rome. But what you'll see is when we start the demos, that leveraging, go ahead and start the demos, is you'll see 3 sequences. You'll see first a full HD sequence, where we're taking and rendering a scene in full HD. You then will see the demo transition to quad HD. And that's where you see kind of it move to the quad HD. And then finally, you'll see it transition to a full 4K resolution. You can actually hear the fan spinning up as we start to run in greater capacity. And as these finish, you'll see that the Skylake system it takes about roughly just over 30 seconds to finish. A dual Skylake system. So again, 2 Intel 8180Ms. On the far right-hand side, you see the Naples-based 2-socket system that finishes incrementally faster. This is again based upon the leadership floating point performance that we have today. So the world record floating point benchmarks that we shared with you is how we accomplish this objective. And then you see in the middle, probably the most interesting to all of you, is the fact that we can now, with a single Rome solution, actually beat both the Skylake 8180Ms as well as the Naples 2-socket solution as well.
Which Naples EPYC chip is it?
7601. So it's our top of stack.
What's the price double again?
Okay. So I think I'm going to move over here, and then again, you guys can get all the pictures you want. But I think as we kind of finish, you guys getting the pictures, I think that obviously a big day with lots of feature reveals, lots of customer momentum and news. But at this point, we'll open it up for questions.
So when is Rome due to come to market again? I know it's first half of 2019.
All we said is it's available in 2019.
Does C-Ray use AVX?
It uses floating point based instructions, yes. So it uses AVX based instructions.
AVX2, AVX1, or
I think it's AVX2 based instructions. Yeah.
Cloud services. Do you have any announcement about Google?
Wow. No announcement about Google. Obviously, we're very excited to be with the #1 player in the market in AWS.
Yeah.
Other questions?
No way.
We fully answered your
So how
question.
soon before this trickles down to consumer land? Because it all enterprise stuff in military, it always comes to consumer, but it just we see the future in these parts first.
Yeah, I think one of the things that you saw in Mark's presentation when he talked about Zen 2, and even before then when he talked about the momentum in Ryzen, the momentum in EPYC, and the momentum in Ryzen Mobile, you actually saw in the first generation of Ryzen a conscious decision to bring Zen technology to the consumer market first. I think you actually see in this generation the opposite. The data center needs this computing capability and horsepower, and we have a competitive positioning opportunity where it will come to the data center first. But know that the consumer adoption cycle is quite fast and will be shortly thereafter. So they'll be very close to each other. Yes?
I may have missed that in Mark's presentation, but is the fabric still the same that he used with Zen Generation 1? To interconnect all the dies and also the IO chips?
Yeah, so it was a subtlety that he mentioned, but he talked about next generation Infinity Fabric. And if you think about going back to the architectural presentation that he showed, how you have a single IO die where all of the IO memory controller activity is, that couples to the 8 individual core die, up to 8 individual core die. That is actually an evolution of Infinity Fabric. So think about it as an improved Infinity Fabric. So it's Infinity Fabric, but with changes given the fact that the architectural split is different between Naples and Rome.
I would have first guessed that you would use something like a ring bus based on Infinity Fabric. Is that correct?
We don't want to get into the architectural details of the IO die, but know that it's a very high bandwidth, highly scalable, non-blocking architecture that should be able to fully feed all those high performance Zen 2 cores. Yeah.
So the CPU chiplets have 8 cores each.
Correct.
Is that still 2 CCXs?
Not getting into further architectural detail, but great question.
Thank you, I guess.
Yeah, thank you. Yeah, you're welcome, I guess.
What kind of IPC gates do you expect Zen Plus versus Zen 2?
IPC?
What per clock? 4 versus 4.
Not commenting today, but no, it will be a good improvement.
How about power consumption of this demo system? Roma's power consumption is lower than the competitor or the higher?
Well, one of the things, you guys are getting all of the right specs right away, so we might as well launch today, evidently. No, I think, in all seriousness, we talked about, and you saw Lisa talk about, 3 generations of platform compatibility. Naples, Rome, and Milan. Very important, which means that power provisioning and power consumption, we have to be able to support that across 3 generations of platform. So we expect that we'll have a power envelope that would service existing Naples systems.
Yeah, in this demo system.
In this demo system,
Yeah, we're not commenting on the thermals for this
Quite
particular.
simple. If it's 2 times performance, it's the same clock, because it stated that on the same performance you get 50% lower power.
I think this is, thank you for the color commentary. I think if you look at it, I think this is one of the big benefits of the 7 nanometer technology, right? Is so thinking about, to kind of recap what Mark talked about, the analog technology does not scale that well, okay? So it makes sense to keep that in 14 nanometer because actually 14 nanometer technology, the wafers are cheaper to manufacture. Whereas you look at, 7 nanometer, for a lot of the digital logic, cores and caches, scales very well. So that's where moving to something that has higher performance and lower power really pays off at the system level. So this is where this next generation of chiplets architecture-based approach is putting the right process technology with the right design elements. Yeah?
Does that mean that in the chiplets there are no I/O capabilities except for the IF fabric?
Ooh, that's an architectural question. I think I'll not comment, but know that the things must coexist together. They must be together to function. Yeah.
Given the cycles for replacing expensive data center equipment must be long, and enterprises and companies like to take their time in refreshing. I mean, do you see your partners forecasting, a lot of upgrade in data centers in 2019 after you launch, or do you think it might be delayed for a year as companies try to eke out, the full ROI? I mean, clearly there's massive benefits in what you've shown us to power and licensing and all the rest, but just because that's available doesn't mean the companies are going to immediately go to it, that whole N-1 or 2 thing.
Yeah, I think it's a good question, and we actually had a question earlier about kind of the adoption cycle and how do we think about that set of opportunities and challenges. So I think if you look at it, I think we've shared, and I think most people know this, but maybe to kind of double click is, there's certain subsegments of the market that move much quicker. Okay, so for example, when you look at for example, cloud service providers, tier 2 web companies, high performance computing, they tend to move faster because they want latest access to technology, and they have the ability to kind of scale very, very kind of massively, very quickly. Whereas enterprises, you heard from Forrest, they tend to be kind of conservative, right? So they're kind of like, hey, am I going to be able to trust AMD again? Are you back in the market for real this time? And what we've, and again, what we've looked at and what we've seen is people are evaluating and now adopting EPYC. And the key thing about the roadmap that Lisa shared is because there is platform compatibility, that investment that people make today is one that they have a sure future in for at least 2 generations of technology. This is different than where our competitor is today. So I think the cycles are longer. There are portions of the market that move faster, but I think people are finding solace and real kind of confidence that our roadmap is solid, we're executing, and they have 3 generations of socket compatibility to really rely on.
And you probably just need a firmware update as opposed to replacing an entire system or motherboard.
And again, I think one of the things that we shared was that that Rome will be able to drop into Naples platforms. So people will have the ability to leverage the goodness that is Rome in Naples.
I think there's also
will
a...
it function in all its features, or some features might work?
So there are...
Lisa wasn't completely clear on that matter.
Yeah. I think there are going to be certain attributes of the Rome design that would require new materials, new technology, but we definitely will have the capability to drop Rome into existing Naples platform and deliver great performance.
So what are we going to say, Daniel?
Well, so back to your point, I think there's a macro view of this. It says for customers to upgrade, they need a compelling reason. And if we stayed on the same cadence that we've seen from the competition, that looks to be not 3.5 years, but more like 5.25 years. What we're seeing with AMD EPYC, and now that we're showing Rome, we're actually providing them a reason to upgrade. Maybe they have software licenses that are going off cycle. Maybe they've got contracts that are preventing them from continuing the hardware. But now what we're saying is you can actually right-size your workloads. You can actually do something that's materially different than what you've done before. And so we actually think this is going to accelerate the refresh of many data centers. And there's a conversation that happens on-prem, and then there's a conversation that happens off-prem. The speed at which this is being adopted in the public cloud is a function of growth. The speed at which this gets adopted in the on-premise private cloud space, it's a function of efficiency. It's the ability to go and take technologies that are eking out way more performance than they've ever been able to get before with actually less spend. So they can go and they can replace that hardware and actually save money. So that's good for them.
It's the kind of right-sizing people like, except Intel.
Except
So with your announcement of 64 cores in one socket and Intel's announcement of cascading yesterday, how do you see the market share between 1P and 2P servers evolve in the next couple of years?
Well, I think it's a great question, around how do we think about kind of 1P versus 2P. And rather than prognosticate kind of how share will evolve, I'll give you some kind of insights and examples. So if you look at a lot of what we shared today, we shared kind of some of the cloud experiences. People tend to say, hey, cloud is all about kind of, scale out, it's about core density. Well, you see, major players like Baidu, you see major players like Dropbox, you see all these companies adopting one socket. So you can actually cover a large portion of the market with the Naples one socket solution that we have today. Now, when you take and evolve that into Rome, right, we now have shown in a demo today, and there will be more to come, how with a one socket that we have today, we can cover the entire two socket market. So we now have moved from, in the Naples generation, the ability to cover maybe the bottom 70% of the market with one socket. We now have the ability to cover and lead what is the entire two socket market today with a one socket offering. So we think that one socket will continue to accelerate in terms of its adoption.
Are there any concerns you may not have enough memory bandwidth for road, given that it's not changed between architectures or sockets?
Great question. There are other things besides the number of channels that dictate how the cores will perform, and those are architectural details that you'll see in time. So we have a plan of how we're going to make sure that those cores are properly fed.
So no worries.
Watch this space. We'll prove it to you. Yeah.
Intel is developing CPU and GPU, but they are also developing networks, SSDs, accelerators, FPGAs, mortgages. They have a complete ecosystem, and when we talk to customers, we don't listen that it's an advantage already in India. Do you see kind of competition on that?
So the question was really, our competitor has the ability to provide drives, NICs, and actually in many cases entire systems, right? And how do we view that as kind of a potential liability or a vulnerability? We actually view it as a strength, because I think people are becoming increasingly concerned about being under the control of a single supplier. And we have leaders in the market that we've been partnering with, companies like Broadcom, companies like Mellanox, companies like Samsung, companies like AMD, companies like NVIDIA, that are part of the open ecosystem that EPYC supports. So actually, even though there is a capability, that they have the capability to offer different portions of the portfolio, we see people wanting to have diversity in the supply base, and we see many like-minded partners and very strong and powerful companies that want to partner with AMD.
Well, in an example of that would be next week we'll have the Supercompute Conference, the Global Supercompute Conference. There we'll be demonstrating with our partners on multiple fronts, whether that be FPGA, whether that be memory, storage, etc. And so our strategy is very much an inclusive strategy. We're not going to go out and develop a bunch of adjacencies anytime soon. May never do that. The reality is we want to play with the broader ecosystem. And we feel like when we look at that from a technology perspective and from a go-to-market perspective, we can bring our platform partners together and create a better solution for customers that will give them the value that they need.
And it allows us to focus on what we're good at. You heard from Lisa, like, very emphatically, I think you probably count that as we're all about high-performance CPU and GPU, and that's what we're going to focus on.
I need solutions like Optane persistent memory, for example. You don't have anything to offer for that, and your partners
Optane?
Persistent memory.
Yeah.
Yeah, so if you look, for example, if you're talking about PCI-based Optane memory, works great with EPYC, right? Works great with EPYC. So, other questions?
So, just a question from the stream, and I'm sorry I don't know the answer, but Intel's got 2P systems. You're showing off a 1P system here. But do you have 2-socket motherboards? Could you put 2 of these and get incredible performance out of it?
Yeah. So what we have here in terms of our reference architecture, our development platform, as well as the AMD-based reference architecture. It's codenamed Daytona, so if you hear Daytona, that's what it is. Those are both 2P-based implementations. So expect that, as Forrest alluded to, 2P realm should be really, really good. Other questions? Yes?
Do you get much interest around the vertical integrations like gigahertz very important, or is it just the fact that your gigahertz is allowing general signal
So this is one of the things that that is, I think, a very kind of strong capability that we offer in the EPYC stack. Is even though people tend to think about that top of stack highest core density, we also offer low core count high frequency versions. And actually, this is something that I would ask you to watch this space very closely. That we're working on. But we do see that there are people that prefer either for core licensing-based reasons or for the workload affinity that will choose lower core count, high-frequency based devices, or things that potentially might be memory bandwidth bound. So we actually see, for some examples in the HPC spaces, we actually see people that are buying kind of 16 and 24 core based devices because the core to memory bandwidth ratio is higher. So we see that as an opportunity where people can buy down stack and not have to kind of, compromise on features or other things that you would have to do in kind of going down a precious metal tier with our competitor.
Time for one more question.
Yes. Any one last question? Yeah.
Okay. Do you have any more information about the ANSYS fluid performance increase of 1%? Is that low just because ANSYS also will scale up quite well?
No, we actually, if you look at it, we actually have a handout that we could provide you that would be that gives you kind of the details of how do we get to the 25% performance benefit with ANSYS. We can take that action and make sure you get a copy of that. We have a performance brief that we can share with you on that. Okay, great. Well, thank you very much. Appreciate you being here, and again, thanks for your time. Thank That's correct. So, yeah, so think about deterministic performance.